Hi, this is Team 19. Our team members are Jackie Chen, Ke and Guanchao Wang. Here is our final project proposal, and our idea is to build a distributed cache. So I will introduce the motivation, brief description, algorithm, application, as well as new technology challenges for this project. So first, motivation, why we want to build a distributed cache. In recent days, many organizations have distributed environments with users at remote locations connected via fairly slow, high latency links. It's often a challenge for users at these locations to access data at the hub locations, with the end users experiencing slow access. So, we want to improve user experience to get data. An idea is to use a hosted cache on server. So, one server at each location cache data for users. It's simple, it helps, but there is bottleneck, there is one point failure, it's not stable, so we want to build a distributed cache. What is a distributed cache? There is no dedicated server to cache data. Each end machine has its own local cache, and clients will be able to get data from nearby machines in most cases. How can users benefit from it? In distributed cache, there is no slow download from a central server in most time. There is speed up in downloading through locality and parallelization, because we can get data from nearby machines like in a local subnet, and we can get data simultaneously from several machines, and it's fast, it's reliable. Of course, we need some algorithms and techniques to build it. So, first, hash value. It will identify data based on content. So, every time a client wants to get data, it will still need to send a request to server to obtain a hash value. And then it will use this hash value to request data from its peers. This brings an advantage. If data on source changes, a new hash is generated. It will prevent clients from getting outdated cached data. Here is a more detailed description about our algorithm. So, a client who wants to get data, let's call it client 1, will first issue a request for data to a server, and our server will respond a set of identifiers, mean hash value, for the chunk of content the client requested, and then client 1 will search local subnet machines to get the data from machines who already downloaded and cached the data. It will use a multicast protocol send over UDP to send the request to its peers. But what if the peers don't have the data that client 1 wants? In this case, client 1 will issue another request to the server, and server will respond with the request data. Client then adds this data to its local cache. It's very similar to a client-server model in this case. But then, if another client 2 wants to get the same data, it will first issue a request to the server as before, and the server response identifiers, and then client 2 will multicast its request to that data to search for the content in the local subnet, and then client 1, who already have the data, receives this request, and he will send a response to client 2 to tell it, hey, I have the data you want, just come. And client 2, once received the message, will know, oh, that guy has the data I want, so it will request the content, and client 1 will transmit the data to client 2. After that, client 2 will verify the data against the identifiers it got from the central server. As we talked before, it will prevent it from getting outdated data. So we still need to build an application to show our distributed cache, because it's very like infrastructure. We still need something to show. So our idea is to build a P2P streaming video player like an app. Although our distributed cache will support any kind of file. And finally, let's talk about the technical challenge. We will use Go in our backend design. We will use the HTML5 in our front-end design. They are totally new to us, but we will study and apply it. And because this project idea is very close to system level design, so we need some new ideas in system concepts, like file hash values, like file operations. We need to look up, partition, and transmission. And we also need protocol design, because they need to coordinate communications between clients. Okay, that's all. Thank you for watching.